Hi everyone, welcome to Vedantu JEE English. I'm Diksha, your chemistry master teacher. And as you all requested that ma'am, we want VITEEE EEE session. So here I am. Okay, whenever I promise something, I always make sure that I am on that point, what I promised to you. Right? So I have selected even the last shift that has happened, right? According to that also, if you see chemistry, it is actually very scoring for VITEEE EEE. Reason being, it's not very high level of chemistry they're asking you. Very moderate level, easy, predictable questions they're asking you, right? And here you can easily fetch full marks in your chemistry section at least, right? So let us start with the organic chemistry questions, and then we will do some important questions of physical chemistry and inorganic chemistry as well. So I have taken most of the questions of organic chemistry. Reason being, if you see my video on this channel only, if you see this over here, right, you will see that there is already I have taken one live, two lives in fact on VITEEE EEE. You can see even all model questions of English and aptitude Shreya sir has taken. You can also go through this video here, right? And we have taken other VITEEE EEE session as well. As you can see, VITEEE EEE most important concepts and question that has crossed a lot of views, right? So you can watch that, right? This is for maths, this is for physics, this is for chemistry. So in this particular part, I have taken inorganic and physical questions along with the questions and the concepts in detail, right? So today I'm going to take your organic chemistry questions. So let us start this without wasting any time. Okay, so everyone have your notebook and paper along with you. So everyone let us join and put green hearts in the comment section for VITEEE EEE students. Okay. Yes, everyone, Rishita, Raktita, Mopuru, and Sivdesh, Bharani, right? Everybody, let us start this session without wasting any time, right? Okay. First question on your screen, I will start telling you side by side what are the different topics that they can ask you in your exam, right? So first question here is, which is the most reactive towards nucleophilic addition reaction? Right? So whenever we talk about nucleophilic addition reaction, see, these are some of the standard questions, right? Okay. So which one of the following is reactive towards nucleophilic addition reaction? Nucleophilic addition means on the carbon, there should be electron deficiency. If someone is poor, right, then nucleophile which will get attracted towards something which is electron deficient, right, the rate of reaction will be more in that. So they are asking you most reactive here. So what you can see, most reactive towards nucleophilic addition reaction. So you have to see this carbon, this carbon, this carbon, and this carbon here, which is most electron deficient. That means if someone is taking out electrons here. So here we can see it has electron withdrawing group that is taking out electrons from it, right? Via which things? Two things here, that is minus M and minus I. What about this one? Here it is donating through plus I effect. So donation means more electron density. That means this surely cannot be the answer. Here you have no effect, and in this case what is happening? In this case it is donating through CH3 and it is also taking away the electrons like this. Because the simple part is, whenever on the benzene ring, students remember these two things that will really help you in the exam. Whenever on the benzene ring, if you have a group that has lone pair of electrons, then it is going to show plus M effect. Then it is going to donate the electrons in the benzene ring. Itself, it will lose the electron. It will take away the electrons, right? Okay. Then if you see, you have a group which is double bondedly or triple bondedly attached to more electronegative element. This is less electronegative, this is more electronegative. Always it is going to show minus M effect here. So what it will do, it will show you minus effect here. It will take the electron here and take the electron from the benzene ring, right? So this is plus M and this is minus M. So as you can see, this carbon here is attached to the benzene ring, which is also attached to double bond with oxygen, which is more electronegative. So it is going to take the electron from the benzene ring. That means this is definitely not electron deficient. And here you see no effect. So answer will be D, which is showing you electron withdrawing group here. So answer is going to be D is the correct. Session duration will be 1 hour or 1.5 hour. Okay, only most important questions I have picked here, right? Okay, I know you have less time, so according to that only the session will be. Don't worry about that, right? Okay. Now, next question, let us see that. Next question, students, try to answer the questions also, right? Okay. The product formed in the reaction of cumene with O2 followed by treatment with dilute HCl. Now, all the naming reactions should be on your tips, right? All the naming reactions. If you're thinking, ma'am, I have no idea right now what to do, just go through my naming reaction and important reagents video. Go through that. That is just 1.5-hour video. That will really help you. And I promise you that you will see questions from organic chemistry from there only, right? Okay. So the products formed in the reaction of cumene with O2 followed by treatment with dilute HCl, right? So here we are talking about cumene process. What is cumene? Cumene is when you have isopropyl on the benzene. That is CH, this is CH3, this is CH3, right? Now, whenever you add oxygen here, it has a peroxide linkage. That means this is converted to, this is COOH, this is CH3, and this is CH3. This also they can ask you. Sometimes they also ask that what is the intermediate that is formed here, right? After that, doing the hydrolysis, you get two products. That is, I can see in the options. Second one is acetone. So let us see how many of you have answered it. B. Very good. So answer is B is the correct answer. Dow's process, cumene process, diazotization process, all are very important for you, right? Next is conformers. Okay, so conformers, how to remember, right? First is in ethane and cyclohexane. In conformers, they will ask you questions from stability only, right? Okay, so one thing to remember, that in ethane and cyclohexane, which one of the following is more stable conformer? So if you talk about ethane here, in ethane, see, firstly, ma'am, what is eclipse? To all those students who have no idea, ma'am, what is eclipse, what is staggered, we are totally dependent on you. See this, right? So, if this is one structure, one is representing the backward atoms, one is dotted will represent the forward atoms. Okay. So here it is one some atom here, some atom here, some atom here. If you have zero angle between this, let's say one layer of atom, one carbon is in front, one carbon is in back. The atom that is attached to this carbon, the atoms that is attached to this carbon, these two are representing backwards and front. So one is solid is representing, let's say, backwards, and dotted is representing, let's say, forward. Or you can say more accurately is solid is representing the forward, backward is represented by dotted, right? And one other is when you have 60-degree angle, right? So here what we have, this is called eclipse. Eclipse is, eclipse means when something hides something, okay? So like sun eclipse, right? Like moon eclipse we have, right? So here this is called eclipse, okay? And this is called staggered. Now you yourself feel that, ma'am, this will cause more repulsions. More repulsion always means less stability. That is why always staggered is going to be more stable as compared to eclipse here. Next is regarding the conformers of cyclohexane, right? So conformers of cyclohexane, it's very simple. Conformers of cyclohexane are, let's say you have chair conformer, you have boat conformer, you have twisted boat conformer, right? So out of this, chair conformer is the most stable conformer here. So answer will be, yes, answer will be staggered and this. One more question related to this, I'll tell you that they can ask you. One more question related to this, okay? That is simple. Those who have no idea, those students also can answer this, okay? See, there is one structure which is anti and one is gauche, okay? So usually what is anti? Let's say these are the two structures. This question also they can ask you regarding propane or especially butane. This question is asked, right? So if you talk about anti-structure, in anti-structure you will have things like this. Like this is CH3 group and this is CH3 group. This is H, this is H, this is H, this is H. Right? This is, I am talking about butane. One carbon here, one carbon in front, one carbon in backwards. And in this carbon, you have one CH3 group attached. In backward atom also, you have one CH3 group attached. This is what I have formed. If CH3 are anti to each other, gauche means they will be at this much repulsions. Okay, they will be at 60-degree angle with each other. Now, in usual case, what we say that because here in anti you have less repulsion, so always anti is more stable as compared to gauche, right? But what makes this question important is gauche effect. Okay, so students, what is gauche effect? Anybody in the chat box, what is gauche effect, right? So one question they can ask you regarding this simple question, or they can ask you this very, very repeated question, that is anti and gauche. Anti is more stable if there is no hydrogen bonding. Let's say you have a structure, where you have hydrogen bonding, right? Let's say you have a structure where what you are seeing is hydrogen bonding. Here you have, let's say you have CH2OH, here you have CH2OH, right? And here also you have CH2OH, or directly you can also add OH here. Here also OH can also be there. Like totally your choice, whatever you want to add here, it doesn't matter. What matters is if there is any hydrogen bonding involved, right? So we know that even now, this is the gauche structure, right? And this is the anti structure. But we know that here we will have hydrogen bonding. That is why gauche is more stable, and that is called gauche effect. That is called gauche effect. Very, very important for your exam, right? That is called gauche effect. Where you have hydrogen bonding, that will be more stable. In general case, anti is more stable as compared to gauche. Okay, understood, students? Next question is how many hyperconjugable hydrogen atom does this molecule have, right? So always remember, hyperconjugation is not very, very simple question. Very simple. Yet if you have not gone through hyperconjugation, you will find it, what is this, ma'am? Right? Directly what you have to remember, whatever is the mean thing, that mean thing can be carbocation, that can be a double bond, that can be a free radical, that can be anything, right? The carbon that is attached next to it, this carbon, and this carbon, that is your alpha carbon. First condition is alpha carbon should be sp3 hybridized. Okay, what I am writing? First condition is alpha carbon should be sp3 hybridized, and at least it should have one alpha hydrogen it should have. At least one alpha hydrogen it should have. That will make it like it can produce hyperconjugating structures only then. Now we will apply these two things over here. If you draw this structure, students, if you draw this structure here, right, this is the double bond, this is CH3 and this is CH3. Now if you see this, right, I'm telling you the crux of everything, right, that we have discussed. This is alpha, this is the main thing, that is the double bond, right? So this is alpha, this is alpha, this is alpha, this is alpha. If you see how many hydrogen can be there to complete the valency, 2 hydrogen. To complete the valency, 2 hydrogen. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Total you have 10 alpha hydrogens. That means you will have 10 hyperconjugating structures. Always remember, number of hyperconjugating structures, number of alpha hydrogen is equals to number of hyperconjugating structure, and more the hyperconjugating structures, more will be the stability of the compound, right? So here we can write C is the correct answer. Very good. I can see that in the chat box that ma'am 10 is the correct answer. Very good. Next question is here. Now this is, I would say, from one of the most important reactions and most important reagents of your organic chemistry that is repeatedly asked in the exam, right? So first is 2-bromopentane is heated with potassium ethoxide. Now let us see how many of you actually identify this thing. Potassium ethoxide is what, students? Let me know in the chat box. Are you able to identify what kind of reaction is this? Ethoxide means C2H5 ONA, that is ethoxide, right? Potassium means K, here it will be, right? Now this thing, ma'am, what kind of reagent is this? What kind of? Very good, very good, very good. So here it is nothing ethanol. Do you know This reagent hello. Hello, I'm so sorry. I'm so sorry. Where I was when I was teaching you this. I am so sorry, ma'am. No audio. Oh. See how consumed I get when I'm teaching. I have no like host. Like, what is going on? All I see is board and reactions. That's my energy when I solve organic chemistry, physical chemistry, inorganic chemistry. The kind of energy that you should have in your exams, right? No, nothing I see when I am solving the questions. Okay. So everybody, now let us see this. Okay, I'll again solve this for you. Again, I'll do this for you, right? So basically here what I was talking about is that here you have potassium ethoxide. That is C2H5OK. That is nothing but alcoholic QH. Now you have two kind of reagent. One is aqueous QH, other is alcoholic QH. So if you talk about alcoholic QH and aqueous QH, let us draw the compound firstly here. That is 2-bromopentane, right? So now here, now what if we are using KOH, but that is aqueous, right? So directly it will do the substitution. So Br will be substituted by OH, no worries, nothing, right? But what if here you have KOH alcoholic, right? The reagent is C2H5OK. This just to confuse you, they have given it like this, right? Otherwise, what you will do here, here directly you will eliminate the dehydrohalogenation. One halogen will be eliminated. Now the question is, ma'am, here you have CH3. Here you have CH2. So two products can be formed here. If you replace hydrogen from this side, this product can be formed. And if you replace hydrogen from this side, this product can be formed. So here, which product you will choose, A or B? Everybody let me know in the chat box. A or B. We will choose this product, not this product, because according to Sedgwick rule, more alkylated, the one in which double bond has more alkyl groups attached, that is preferred, right? So that is the major product. So answer will be, now here again the question is whether trans or cis will be formed, right? So I can see the answers in the chat box that ma'am, trans is formed here. Reason is because trans always has less repulsion. If you see, this is your trans, this is 1, this is 2, this is 1, this is 2. One more question I am telling you here, right? One more question I am telling you here regarding GI, right? See, if they ask you which of the following shows geometrical isomer, this is 1, this is 2, this is 1, this is 2, right? So beta, in this case, remember one thing, let's say this is 3 or let's say this is 4, okay? Remember one thing, 1 should not be equal to 2, 3 should not be equal to 4. If you're talking about geometrical isomers will be present only then. Geometrical isomer means cis and trans. If you have two same atoms on the opposite, that is trans. If you have two same atoms, right, side by side, that is called cis. Okay, so trans will have less repulsion. That is why we will answer C is the correct answer here, right? Not cis. This is where students can get confused that which is the correct answer here, right? Next question is based on the stability of the carbanion. Now students, one rule I want all of you to have it in your head, that should be crystal clear in your head, that is BARHI. Everybody spam it in the chat box, BARHI. Ma'am, what is this Barhi? Trust me, this will make questions of stability of intermediate, like in seconds you can solve the questions, and trust me, you will not have any confusion after that. You can easily solve this. Sometimes we know all the effects, still we are not able to understand which will be more priority, right? So this means back bonding, this means aromaticity, this means resonance, this means hyperconjugation, and this means inductive effect, right? Okay, this is aromaticity, this is back bonding. Now, firstly, we will look for back bonding, right? Is there any back bonding in any of the compound? Back bonding, ma'am, means what? In back bonding, like you have oxygen here, and here you have lone pair, and here you have carbocation. One is electron rich, other is electron deficient. That is back bonding, right? That is called back bonding. Or you can have one boron here and one carbanion here. Now, carbanion is electron rich, but boron, we know that from inorganic chemistry, boron is electron deficient. That is also back bonding, okay? Just remember, electron rich and electron deficient, if they are on the adjacent position, then back bonding will happen. Here we can't see any electron deficient atom in place of next to the electron rich, right? So that is back bonding is not possible here, right? Next is aromaticity. Can you see aromaticity should follow PCC? What is PCC? Planar conjugated. From this question, I am revising the full GOC, right? I am revising full GOC, right? That you should apply here. PCC means planar cyclic conjugated, right? So if you see here, planar cyclic conjugated, that is there only in this compound, which is complete conjugation is present. Cyclic it is planar also. Electrons are 1, 2, 3, 4, 5, 6. It has 6 pi electrons. That means 4n plus 2 pi electron it has. That means it is aromatic in nature. For this, students, always remember one table. I am drawing it for you on the side part here, right? That is, if you have important charts I am giving you for your exam, right? Let's say you have PCC. If PCC is followed, if PCC is not followed, then it is non-aromatic. PCC is not followed, maybe it's not planar, it's not cyclic, it's not conjugated, it's non-aromatic. If PCC is followed and there you have 4n pi electrons or 4n plus 2 pi electrons, this is anti-aromatic and this is aromatic in nature. And if you see the stability, aromatic, then you have non-aromatic, then you have anti-aromatic, is the least stable compound. If you see any compound, they have given you stability of intermediate, any compound comes out to be anti-aromatic. That will be least stable among all of them, right? Least stable compounds are anti-aromatic compounds. Understood? So here what we will say, that fourth is going to maximum stable. So this is eliminated, this is eliminated, right? Okay, students have answered C is the correct answer. Let us see that, right? After this, let us see if there is any resonance here. Resonance is present over here, right? So that means after that you will have third. Then let us see hyperconjugation. In carbanion, you don't have hyperconjugation, right? In carbanion, hyperconjugation is not valid, right? Unless and until you're talking about minus H, which will not be there in your syllabus, right? So last part is inductive. So here we know that this is carbon, which is 2 degree, and this is carbon, which is primary. And we know that in the inductive effect, which is more dominating. See, simple thing is, if something, beta, one more thing I am telling you about your carbanion stability. I am writing it here, right? I am writing it here. Remember that if you have negative, if you have, let's say, negative, if you have something negative and you are donating the electron, somebody is already under stress. If you are under stress, I am giving you more stress, you will be like, ma'am, please go. I don't want more stress, right? If I come here and start wasting your time, you will be like, ma'am, I don't want to listen to you, right? So here, if I am teaching you something which is useful for you, right? I am taking away stress from you. then you are more stable here, more happy, right? So negative needs negative. That means a carbanion needs something which is taking out stress from them. Then it is becoming stable. And if you have carbanion, then if you give the electron, if someone is poor, you give the money to them, they will be happy, right? But if you take the money from them, they will be unhappy here, right? So here what we can see that in the carbanion, here you are giving the electrons with one effect, with one CH3, and here you are giving the electrons from two sides. Definitely this will be unstable. So second will be less stable as compared to first. So answer is A is the correct answer here. Right? It needs less electron. It wants that I am already negative. Don't give me more electrons. I am already full of electrons. Right? So that is the reason B is going to be the correct answer. Is that clear to everybody? Very good. Very good. I can see your energy in the chat box. So that is B is the correct answer. Very good. Right? Okay. Super example. Yes. Now you will remember this forever. That okay. Negative means stress. Positive means money. Okay, just remember this for your exam, right? Acha, one more thing regarding what kind of question they can ask you from GOC. This is what I told you, that when I'm saying that this is going to be your important session, that means not only questions, but I'm going to tell you some important paper leaking questions I'm going to tell you, right? So this is HA, right? Same kind of question they can ask you based on acid. Rather than giving you carbanion, they will give you some HA. We know that if they ask you the stability here, remember that more is the stability of this carbanion, more will be, this will be a better acid, right? Acidity depends on the stability of carbanion, and stability of carbanion, you have already answered that, ma'am. We can easily answer that, right? Okay. Next is, ma'am, pKa value is inversely proportional to acidity. Remember that. Okay. Next important thing is basicity. If they ask you basicity in any question, remember that basicity is directly proportional to number of, or you can say directly proportional to electron availability. Electron availability. If on that species you have more electrons availability, that will be more basic in nature, right? Directly you can answer that, right? Okay. Now that was about GOC, how they can ask you the questions based on GOC. Now one question is based on annulenes. Now tell me in the chat box, how many of you have studied annulenes? Annulenes is a part of aromaticity, anti-aromaticity and non-aromaticity, right? Usually what we see, ma'am, annulenes are very, very difficult. No, beta, they are very easy. I'll tell you how, right? Annulene is monocyclic, like you have benzene, right? Benzene is the example of 6 annulene. The number of pi electrons or the number of carbon will represent the annulene number. So we call it 6 annulene because it has 1, 2, 3, 4, 5, 6 carbons. This is called 4 annulene because it has 4 carbons. Okay. So according to that, we name the annulene. Now you will have always even number of annulenes. From 4 till 14, you can have your annulenes. In fact, till 18, you can have the annulenes. From 4 till 18, you can have the annulenes. But remember one thing, right? What you have to remember, the non-aromatic annulenes. Non-aromatic annulenes, what are these? 8, 10 and 12. Just remember 8, 10, 12, that's it, right? Don't make too much pressure of annulenes in your head, right? If they ask you very simple and direct question, they will ask you 8. If you see 8 means 1, 2, 3, 4, I think that is going to be 1, 2, 3, 4, 5, 6, 7, 8, right? This is your 8 annulene. It does not exist as like this, rather it exists in a tub-like structure like this. Okay, it exists in a tub-like structure like this. That is why it is non-planar, hence it is anti-aromatic. So they can ask you why 8 is non-aromatic because of its tub-like structure. 10 and 12 are non-planar and that is why they are non-aromatic. Reason being because of their hydrogen repulsion, or you can say angle strain. Ma'am, what about 4, 6, 14, 16, 18 annulene? You didn't told us about that, right? So now regarding other annulenes, what you have to remember is number of carbon atoms. Let's say they ask you for, they are asking you for 14 annulenes. 14 annulene means it will have 14 pi electrons. Number of that annulene will represent the pi electrons. 14 pi electrons are fall into the category of 4n pi, 4n pi plus 2. If you put 4n plus 2, 4n plus 2, if you put n is equals to 3, 3, 4, 12, 12 plus 2 is 14. That means it is going to be aromatic in nature. This is what I'm telling you. If they ask you 18 annuline, don't learn anything that, okay, 18 annuline will be what, ma'am? We forgot that in the exam hall. You don't have to learn anything. That is 4. If you see 4n plus 2, again, if you put n is equals to 4, that is 18. Right? Again, it is aromatic annuline. Let's say, ma'am, let's talk about 16 annuline. 16 annuline has 16 pi electrons, so it will be 4n pi if you put n is equals to 4 here. Right? Okay, that's how you will answer this. Is that clear to everybody? Is that clear to everybody or not? Right? So maximum the amount of question that they can ask you from GOC that I have covered from one question only. Right? Okay, students, is that clear? Right, everybody? Now, next question is ring expansion, ring contraction, and ring carbocation rearrangement. Okay, students, ma'am, we can't do this, ma'am. Please, ma'am, easy question you tell us. I'll tell you, I'll make this easy for you. You give me just 2 minutes, okay? I'll make this easy for you, right? Now, do you know one thing that in SN1 mechanism, SN1, 2, just remember 1, 2, 2, 1, 1, 2, 2, 1. What do you mean by that? If you have one SN1 mechanism, that means it is a two-step mechanism. In two-step mechanism, you will have carbocation, then nucleophile will attack, right? So SN1 mechanism means there will be formation of carbocation here. That is clear, right? Now, if you put this here, if I draw this and if I take X negative from there, I'll get this carbocation, right? Now, this is only possible if it is a SN1 mechanism, right? Now here, ma'am, what is ring expansion contraction? Simple thing is, if you have positive charge outside the ring, positive charge outside the ring will cause ring expansion. Just write it here. Positive charge, where you want to write positive charge outside ring, then ring expansion. Without thinking, do ring expansion. Ma'am, how do we have to do ring expansion? Very simple. Put 1, 2, 3. Okay, now what you will do? Simple thing is, you will draw the same thing here. But now attach 1 and 3. Okay, ma'am, attach 1 and 3. So I'll attach 1 and 3. Then put positive on 2. That's it. You have your compound ring expansion. That's it. That was ring expansion, right? So now this does not look good. So rather, because pentane exists like this, so now I will add OH negative because we are adding water here. So I'll add OH negative here and this will be your answer. So answer is A is the correct answer, right? Okay, so A is the correct answer. One student has answered OH here. We think this should be the answer if this was SN2 mechanism. Because in SN2 mechanism, you don't have any carbocation formation. In carbocation, there will be ring expansion, there will be ring contraction. So take care of ring expansion and ring contractions, okay? Right? That I have told you where you will use. Now, I know you are a little bit scared after seeing, if you are seeing this for the first time, then you are like, ma'am, okay, this was a good question, right? So, now, ma'am, will I be able to do that in the exam? Let's see it from this side. This is not the same question. I'll give you the hint. This is a question of ring contraction, right? And trust me, in VITEE EEE, they don't ask very high level question from ring expansion, ring contraction. Very high level question of ring expansion and contraction are asked in JEE Advanced. In VITEE EEE, the state exam or especially university exams, right? They ask you in VITEE EEE, good questions are asked. That is why this concept they can ask you, but from a very simple perspective, right? So again, it is SN1 reaction. That means it is carbocation formation. It is there, right? So here what you will have, this is the cyclobutane, right? Take out X negative here, you will have positive here. Remember, whenever you have on the ring, you have the positive charge, you will apply ring contraction here. Ma'am, how we will do that? Same copy paste that we did in ring expansion. This is 1, this is 2, this is 3. What I'll do? Join 1 and 3. Okay, ma'am, we will join 1 and 3. Now put positive on 2. Okay, ma'am, put positive on 2. Right? Now write it beautifully like this. Okay, ma'am. Now you have to add OH negative here. Very simple. OH negative is added there. So it will be 1, 2. This is OH. That is CH2OH. That means C is going to be the correct answer. Let me see how many of you have answered it. Very good, very good, very good. Suresh, Sunita, Shirish, very good, Kritika. Okay, very good, very good. Right? Very good. Now, very good. One student has also answered. Shirish is saying, ma'am, dancing resonance. Very good. Now, this is very stable compound due to dancing resonance. Right? This is very stable due to dancing resonance because, you know, like you dance, similarly, this will dance. How this dances, those who wants to know this, how this dances, okay? So, when you're dancing on your one leg, sometimes you're dancing on both legs, sometimes you have one leg up, right? So how you dance? Similarly, this will dance, okay? So how it will dance? You will have a double bond shifting here. This will be double bond. This is the positive, right? This is the dancing resonance, or this bond can shift here. It can also look like this, double bond, and this is 1, 2, positive here. So that is your dancing resonance, right? That is your dancing resonance. How to find anti-aromaticity? C, if it follows PCC, then you have to check for 4n pi electrons. If there is 4n pi electrons, that is going to give you anti-aromaticity, which are the most unstable compounds. Next question, see, in every question you are going to learn something, right? It's not like repeated questions I am giving you, right? Which of the following alkyl halide is respectively most and least electrophilic in SN1 reaction? Most and least. Now, ma'am, in electrophilic, okay, ma'am, electrophilic you are talking about. In electrophile, that means in SN, least electrophilic in SN1 reaction. Okay, they are talking about SN1. Ma'am, in SN1, you have the formation of carbocation, isn't it? We have the formation of carbocation here, right? Now, if you see the formation of carbocation, if I take Br from here, carbocation will be over here. This carbon will be carbocation. If I take Br from here, carbocation will be over here. If I take carbocation, Br here, carbocation will be over here, right? They are asking you which of the following is respectively most and least electrophilic, right? Okay. So, electrophilic means some nucleophile is attacking here. That is why it is an electrophile. If nucleophile is attacking here, so this person will be electrophile, that person is a nucleophile, right? So here, that means I have to find the stability. Least stable, firstly, I'll tell you, whenever this is a bridge head position. This is the bridge head position. This position is the bridge head position. Ma'am, do we have to know everything about this? No. Till your exam, you don't have to know anything like full detail on this. Just remember, if they give you something like SN1 reaction, this kind of thing is given to you, and Br is attached here, that means positive charge will be over here, which is not at all stable. Why? Because this bridgehead position cannot handle sp2 hybridization. It is like I cannot handle sp2 hybridization because of some angle strain it cannot handle, right? That you don't have to get into, right? Just remember here carbocation or here it is not stable at all. That is the reason first is the least stable here. So first answer we have that C is the correct answer. We have the answer that C. Why third is most stable? Because if you put carbocation here, it is 1 degree. If I put the carbocation here, if I see the carbocation, that will be something like this. Now students, we know that this is a tertiary carbocation. If I put carbocation here, this is 1, 2, 3. But at this position, it is not very stable, right? As compared to this position and this position is more stable. Right, so answer will be this tertiary is the most stable here. So C is the correct answer. Is that clear to everybody? Right? Is that clear? Okay, one more thing regarding this carbocation, right? That is rearrangement. Okay, that is rearrangement. Students, just remember one thing, that whenever you have the formation of carbocation, whenever you have the formation of carbocation, either ring expansion or ring contraction or sometimes ring formation, but ring formation will not be there in your exam, right? You focus on ring expansion, ring contraction, or carbocation rearrangement. Rearrangement means like you have, for example, carbocation, like this carbocation is formed, right? Now what it will do, this will be your hydrogen over here. This hydride will shift on this position and you will have the formation of this carbocation, that is through hydride shift. That is called rearrangement of carbocation. And whenever you see any SN1 reaction, there will be rearrangement of carbocation. Okay, there will be rearrangement. For example, I'll give you one example here, like acidic hydration. Acidic hydration. If you remember, whenever you add acid, H positive, and then you add water, right? For example, in alkene, you are adding it, you form the carbocation. So firstly, you rearrange it. Only then you form the carbocation. Like in hydroboration, oxidation you follow. I'll also give you two other things here. In hydroboration, oxidation, you follow anti-Markovnikov addition, right? In demercuration, demercuration, OMDM, demercuration, you follow Markovnikov rule. Now, anybody who does not know Markovnikov, anti-Markovnikov rule, so Markovnikov rule means negative part is attached to less number of hydrogen. Anti-Markovnikov means negative part is attached to more number of hydrogens. Okay, is that clear? Okay, yes, students, right? Oh my God, I'm so sorry about it, right? I told you to give, like, when I told you to give 100 comments over there, now students reminded me that 100 comments are completed. Now you take the lecture. I thought you guys are not interested. If I would have known that you guys are interested, trust me, even if it takes me night, like day, I have taken classes at 11 p.m. also, right? So it just, if you guys are willing to do hard work, I am always there, right? I am always there with you, right? Okay. So now next question is, okay, so if you see this here, now these are the sequence. Here I am taking up questions. Till now we have done enough of GOC. Now we are discussing question where you have, let's say, zinc HCl. First you should remember that, ma'am, zinc HCl is what? Your double bond O is converted to H2 here, right? Zinc HCl. One more thing, this is Clemenzin reduction. Zinc, usually we have zinc amalgam and then you have HCl, Clemenzin reduction. Okay, in Clemenzin reduction you use zinc amalgam then HCl. But if you talk about Wolff-Kishner reduction, same thing will happen. Double bond O is converted to H2, but in that case what you will have here is the hydrazine. In Wolff-Kishner you will have NH2. I'm just writing it here. Wolff-Kishner, you have NH2, and then you have QH, that is in the basic conditions you have, right? So directly what you can do, firstly, which thing will be formed? 1, 2, 3. This is H2, this is 1, 2, 3. Now, can you tell me what is this? At a very high temperature, 773 Kelvin, when you use Cr2O3, that is aromatization. Okay, aromatization, that means this 1, 2, 3, 4, 5, 6 membered ring will be converted to benzene ring. Aromatization will happen, and hence the answer will be A is the correct answer here. Okay, A is going to be the correct answer here, right? Next question is very important question, very important reaction, that is, can you guess it? Any one of you who can guess this, right? The major product. Firstly, just guess. Don't give me the answer A, B, C, D, right? Firstly, just tell me in the chat box what is the name of this reaction. Just give me the name of this reaction, okay? Right? Name of this reaction. Let me see who is answering first here. Who is answering first here? Inorganic. We are going to take that. Don't worry, right? So very good. That is, ma'am, aldol condensation, right? So here you have alpha hydrogen, here you have alpha hydrogen, right? So exactly which will happen? Can you tell me? You have two answers. Either this alpha hydrogen will be acidic or this alpha hydrogen will be acidic. Which will be more acidic here? Very good. That is aldol. Now you should understand which will be more acidic, students. So we know that this alpha you have and this alpha you have. So exactly what happens, right? So simple thing is, here you already have what you are doing. It is already taking oxygen from this carbon, is already taking electrons from the benzene ring. You should know the reason why this is more acidic in the exam. Who will tell you that this is more acidic? What if you have taken this more as more acidic? So you should know the logic behind that, right? So this is the benzene. You're donating the electron. This carbon is already very happy. This carbon is already very electron rich. That is why this hydrogen is like, okay, this person is acidic, this person is electron rich, so I don't need to, like, he's not crazy about me. This carbon is like, this hydrogen is not totally fallen like mad in love with me. So this hydrogen will be like, I'll go, right? I am ready to go, right? So this person is not fully committed, so I am ready to go. But this carbon, this hydrogen here, this is alpha carbon, this hydrogen here. This carbon is electron rich because this is electron rich. This is electron negative. This is electropositive as compared to oxygen. This is electron deficient. Then this carbon is like this. This hydrogen is like this hydrogen here that is on the alpha carbon. He is like, this is electron deficient. So it needs me. That is why it is staying here only, right? So that is why this is more acidic in nature. Once you know which is more acidic, simple thing you can do, right? What is that simple thing? One thing that you can do is, you can make the alpha, you can firstly, this is the alpha carbon, because of B's wants to abstract the proton. So this will be CH2 negative over here. And then what you can do, this is the negative part, this will attack over here, electrons will jump here, right? So what you will have, this is benzene, C double bond O, CH2, this is linked to this carbon here, CH2, this is linked to this carbon here, where you have the electrons. That is why this hydrogen will be attached here. So here you will have OH and this is CH3. One part is through full mechanism you can solve this. Other thing is through direct method. Ma'am, what is that direct method? One is CH3, C double bond O, H, right? Other is you have benzene and on that benzene you have CO, you have COCH3, right? You have COCH3. Now let us see how I'm going to write it. This is the method of aldol condensation. Those who find aldol condensation difficult because of the mechanism, they can do this method, which will give you always, even if they have given you some complicated aldol condensation, you will be able to answer this. What you have to do? The alpha hydrogen that you are using, right? We are using this alpha hydrogen. You will mark it separately, right? And the carbonyl carbon of other molecule, you will open this separately. Now, beta, what you have to do? You just have to join this carbon with this carbon, right? Join carbonyl carbon with the alpha carbon. So this is CH3, this is C, and this will be converted to OH. Because this hydrogen will be shifted here, this is converted to OH here. So this is OH, this is H, this is CH2, this is C double bond O, this is benzene. Okay, that's how directly you can answer this, right? My benzene is little bit funny, so I'll just have to write the benzene again, right? That is your benzene. Now, remember one thing, this is aldol part, right? You also have to use condensation. So from alpha and beta position, take out OH and H here. So what you will have in the end, this is CH3, this is CH double bond CH, this is CO, and this is your benzene. But sometimes in the option, they don't condense the thing. They don't take out water. They just, the options are just related to this thing, right? So we have to see what are the options that are given to you over here. The options are related to OH only. So that means you don't have to eliminate water here, right? So directly answer will be C is the correct answer here. Understood, everybody? Understood? Yes? Okay. Chal. Now, next is, Now we go through Wurtz reaction. How many of you know Wurtz reaction? Everybody, thank you, thank you. Thank you for the lovely comments. Thank you, Sehar. Thank you so much. Now, 1 bromo, 3 chloro. Now, students, see this. We all know what is Wurtz reaction, right? Ma'am, sodium you add. Ma'am, ether you add. What we do? Ma'am, unsymmetrical is not symmetrical is possible. You have, ma'am, Rx. Ma'am, from here, R is formed through free radical mechanism, right? Okay. Now, what I used? Free radical mechanism. Very important thing I'm going to tell you here, right? Okay. So, they are saying 1 bromo, cyclobutane, this is 1 bromo, if this is bromo, 3 chloro, if this is chloro, right? Now, they are saying on reaction with this, it will give you what? Students, so first is, just remember it follows free radical mechanism, right? So, free radical mechanism means homolytic cleavage here, homolytic. Ma'am, I don't want to get through this homolytic. Ma'am, my brain is not that much working. Okay, your brain is not working, don't worry, right? Just put 1 dot, 1 dot. Like this bindi, you put two dots here, right? So, here it is 1 dot and this is 1 dot, right? Just remember that, like Diksha ma'am always has bindi on the forehead, that unicorn that always is on the forehead. So that is how unit dot is always on the forehead. That is how you will have this dot over here, that is free radical. Now, students, they cram that, okay, this is going to be what, ma'am? Okay, this will join. No, you should remember that this will follow inter or intra, right? Okay. See, always inter is preferred, right? That means only one molecule will join together to give you the answer. So that means this C is going to be the correct answer here. Then, ma'am, why you told us intra? You want to confuse us or not? No. If let's say your interproduct is anti-aromatic. Let's say your interproduct is anti-aromatic. Then you will use intra. Ma'am, is there any example of that? One thing you should be clear on, inter and intra, both situations are possible. Preferred is intra. Intra means in one molecule only those two dots will join and that will give you one bond. That is preferred. But if this is becoming, let's say you have one compound that is, let me just think about any compound. Okay, you have this Br and you have this Br. Okay, this is the compound that is giving to you. They are saying that this is going through Wurtz reaction. Okay, that means you'll be like, okay, ma'am, this is going to form something like this. One dot here, right? Now, the question is, ma'am, if it goes through intra, which is preferred, it will join together and it will give you this kind of product. Now, tell me, is this aromatic? Is this anti-aromatic? Always intra is formed. But if you have, with intra, if you are getting anti-aromatic compound like this, anti-aromatic, which is, it is having 4 pi electrons, then this is not preferred. Then you will have to use inter. That means 2 molecules, these will join together. How they will join together? Like this. They will join together like this, and that will give you the new compound here, right? That is how the product will be formed. Okay, students, got it or not? Is that clear? Simple it is, not complicated, right? Okay, so it's not complicated, right? So I think that's it. Now, next question is Williamson. This is a very, very repeated question. Ma'am, you have given us the answer. I'm so sorry. But here you have to predict. See, Williamson synthesis is Rx and you have RONA. Roxa, Rona, Roar, right? So, Roxa, Rx, RONA. So, this Na and X will be eliminated. You will have ROR, that is ether here, right? Okay. Now, one thing to remember here, if you see this here with NaH, it will have the formation of RONA. This is nothing but this is Rx, right? And here it is giving you nothing but ether. So that is why it is called Williamson synthesis, William ether synthesis reaction. So answer is, I think all of you have answered it. That is B is the correct answer. Okay, B is the correct answer, right? Okay. Now, next is, I think, yes, we have done that. Right. Okay. Now, next is consider the reaction. So this reaction, right? Why I have picked up this question? Because here 2-3 important reactions we can revise from here, right? First is, if something like this is given to you, right, you should know that tolerance, this is nothing but tolerance test, right? And here you are using copper at 573 Kelvin. Now students, I am giving you some important thing here, very, very important regarding your oxidizing nature. So if you have 1 degree alcohol, you have 2 degree alcohol, you have 3 degree alcohol, right? So one is, if you have 1 degree, 2 degree, 3 degree, first case, second case, and this is the third case, right? These 3 cases are very, very important for you, right? First case is mild oxidizing agent. Second is strong oxidizing agent. Third is copper at 300 degrees Celsius. Right? So these are the 3 cases from where they ask you very direct, simple questions, right? In between also. Right? So everybody, I want to see that in the chat box also, how many of you remember that? If you see the first part here, that is 1 degree. 1 degree alcohol in mild is going to give you aldehyde. 2 degree is going to give you ketone. 3 degree will not show any reaction, right? With strong oxidizing agents, like you have Jones reagent. Jones reagent means you have CrO3 plus H2SO4, 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 right? Like you have KMNO4, right? Okay. Here you have CrO3 simple, or you have PCC, or you have PDC. These are mild oxidizing agent. Tollens reagent is also mild. Felling is also mild. Okay, so I have written all the reagents here, right? Now, this is going to give you, 1 degree is going to give you carboxylic acid. 2 degree will give you ketone only. 3 degree will not give you anything, right? Now, last one is when you have copper. Copper with 1 and 2 degree will give you mild answer. That is aldehyde and ketone. But if you have 3 degree, this tell me students, if with 3 degree what it will give you? With 3 degree it will give you which thing? Everybody with 3 degree. And how many of you have liked the session? Right? How many of you, let us see. How many of you have liked the session? See. 417 are watching. 417 or 437 students are watching and likes are 320. Right? That is not good. Right? That is not good. Like should be beyond 700 or something till now. Those many students who have come here. Right? Okay, so everybody do like the session. I don't have this habit of asking this again and again, but it feels really happy. Right? I have skipped my dinner also for you. Right? So that is your duty to like the session. Right? Okay. So now here it is going to give us very good. Can I see that? Yes. Very good. That is going to give us alkene. Yash Raj has answered that. Ma'am, Yash Raj was the first one to answer this. That ma'am, alkene is the correct answer here. Very good, right? Now here, let us go through this reaction again. Right? There is some compound X which is having 1 oxygen. On copper at 3 degree, you should be able to understand that there is some either tertiary, secondary, or primary, secondary, or tertiary alcohol is there, right? Then with that, it is giving tolerance test, mirror is observed. That means silver mirror is observed. Now, remember that tolerance test is given by how many things? It is given by aromatic or aliphatic aldehydes. It is given by alpha hydroxy ketone. Only one ketone that gives tolerance test, alpha hydroxy ketone. I know all of you know aromatic aliphatic aldehyde, but only some of you know that there is alpha hydroxy ketones that gives positive tolerance test. And yes, the questions are asked directly, which of the following will give you tolerance test? You know what, in that case, what they will give you? Alpha hydroxy ketone. And very rare students, alpha hydroxy means you have double bond, on the alpha position you have OH. Alpha hydroxy ketone, right? Okay. Then one is hemiacetal. Hemiacetal also give you ketone. Last one is formic acid also give you positive tolerance test. Oops, formic acid, that is HCOH, right? Okay. Now, here what we will do, ma'am, okay, this we have done. Positive means, in this case, if this many, see, one trick I'll tell you, not even trick, one logic, simple, like common sense I'll tell you here. If specially they have asked you question on tolerance reagent, you should remember this, this and this also, right? If not specially they have asked you this, then you can ignore that. Then definitely they are talking about aromatic or aliphatic aldehydes, right? So here we know that with 2 carbon it's not possible to have aliphatic aromatic aldehyde. So this will be aliphatic aldehyde only. So this is your aliphatic aldehyde. Aliphatic aldehyde. Aliphatic aldehyde is possible with copper at 3 degree. That is possible in what? Aldehyde is possible when you have primary alcohol. Now you know that this is primary alcohol. Ma'am, this is primary alcohol. So answer you already have. This A will be ethanol, right? So A is ethanol, that is your primary alcohol. This is acetaldehyde. Acetaldehyde is CH3CHO. That is going to give you primary, that is going to give you positive tolerance test. That means the answer you can already give. Answer you already have here. But ma'am is here to give you knowledge, right? I am not solving the paper for you here, right? So my duty is not to give you the answer. The answer you can get even from any book, right? These questions are there in books only. You can get the answer anyway, right? You can get, okay, B is the correct answer that is mentioned in the book. What's my duty? To explain you things, right? Because I am present here, right? So this you know how to answer, okay? How to use your brain answering this, right? So that is clear. After this, what they are saying, that you have this thing here, okay? This OH is going to give you some acid you have, okay? See, here you have aldol condensation, right? OH negative on aldehyde, that is going to give you aldol condensation. We know that we have acetaldehyde. Now, students, tell me how aldol condensation will be there. This is, everyone draw it on your notebooks, okay? Draw it on your notebooks. I already told you how to answer this, right? This is CH2 and there is one alpha hydrogen here. One alpha hydrogen here. Now we know that these two things will join. That is, this is CH3. This is C double bond O. This carbon is going to join with this hydrogen here. This is CH. This is your CHO. After that, we will have elimination. Here this will be converted to OH, okay? So this is CH, this is converted to OH. After dehydration, this is converted to CH3, CH double bond CHCHO, right? That is alpha beta unsaturated. Why I solved this? So that you can practice aldol condensation, right? Now only if you have your exam tomorrow also, I don't want to waste even a single minute. I want full revision here, right? Okay, so that is there, right? Next is aldol, we have answered. Now, ma'am, what is this kind of question, ma'am? What is this? In your NCERT, you have a table, right, where you have semi-carbazone, shift base, oxime, all of these are formed. That table is very important. Go through that table. If right now, just write it somewhere in your wall or somewhere, write it, that if you have not gone through that, go through that. I'll also send you that table on the JEE channel, Vedantu JEE channel. Everybody, if you have not, if you have not subscribed to the Vedantu JEE channel, that is totally for free of cost. You can see the link in the description. I'll send you all the important PDF and the chart also in that particular channel only. Now, see this thing. If you have some ketone and you have NH2, here you can draw NH2 and this is Z.